Yeah. And if Schweinsteiger is okay, we'll be fine. But if he's out, then we'll see. All right, we ready? Here we are. Question number 1 that I've gotten about 322 times. Is this class on a curve? I don't really know what that means, but what I will tell you is I don't assign letter grades to numbers until right before the final, right? So I'm going to see how you do on midterm 1 and 2, and then going into the final, I'm going to set the curve, or set what grade buckets go with what grade, what numbers go with what grade, and I'm going to keep it at that. If you guys tank the final, then I'm going to adjust it to your advantage. If you guys do really well on the final, I'm not going to punish you for exceeding my expectations. So that's how it's going to work. If for now you want some guidance as to where you think you are, go with the regular one. 90A, 80B, 70C. My exams are written in a way that I think in order to signal that you've understood the minimum amount of material to be allowed to pass this class, you should be able to get 60 points, right? So I write 60 points worth of questions that I think represent the minimum amount of material you should have absorbed, and the rest of it is to impress me and the GSIs, all right? Is that clear? That's clear. You don't like it, but it's clear. The other question I get, Professor Alfhammer, I'm just much more convincing in person than I am in writing. So can you please make an exception for just me, because I am more convincing in words than in writing, so I can appeal my midterm grade? No. The rules are you appeal your grade in writing. The reason for that is, A, otherwise I'm going to have to schedule 200 extra office hours, and I have 0 time this semester. So for appealing grades, I'm not scheduling extra office hours. If you have a conflict with my office hours, and you seek knowledge that the GSIs can't impart upon you, that you need to get from me, because maybe I'm taller than the GSIs and the air is better up here, so you're hoping that it's going to be better, I'm happy to do that. But for arguing over grades, I'm not scheduling extra office hours. You can do it in writing. You will do this for the rest of your life, is appeal bad decisions in writing. It's a good practice for becoming an analyst or whatever it is you're going to do. You're going to have to make short, clear arguments why something somebody else did is wrong and stupid. So look at this as practice, all right? You like me less already, but that's fine. We got along well last lecture, so I feel like I can spend a couple of points. All right, here we go. Intermediate microeconomic theory. This is your destination check. What we did last time is here we go. Sorry. What we did last time is we looked at long-run production. And if you're still talking, your neighbor is mad at you. If you're still talking after 4 minutes, I'm going to allow your neighbor to pinch you. Okay? Last time we looked at long-run production. We showed that what isoquants are, they're combinations of labor and capital that represent the same amount of production, a cardinal quantity, which is of course different from what an indifference curve represents, which are bundles of goods that represent the same level of utility. We then derived the slope of these isoquants, which we call the marginal rate of technical substitution, which represents the rate at which firms can trade off between using capital and labor and still produce the same quantity. We related this marginal rate of technical substitution to marginal products, much like we related the marginal rate of substitution to marginal utilities, and showed that the marginal rate of technical substitution is just equal to the ratio of marginal products. Right? So a really nice, not equivalent, but very similar equation. And the intuition is very similar too. Then we talked about long-run concepts. Returns to scale comes in 3 flavors: constant, increasing, decreasing. Constant returns to scale is the potato salad production function, where you double all inputs, you double outputs. Increasing returns to scale, you double all inputs, you more than double outputs. Decreasing returns to scale, you double inputs, you less than double outputs. Then we talked a little bit about technical change, which we're going to get back to. But if all of a sudden there's some technological progress that allows you to produce more output with a given set of inputs here, if the ratio of capital to labor stays the same after the technological change, holding prices constant, as we'll see, we call that neutral technical change. It doesn't affect the capital to labor ratio. If the technological breakthrough shifts the ratio of capital to labor, we call that biased technological change. The example we used was teller machines. They shifted the ratio of capital to labor and cash dispensing heavily towards using capital and away from labor. So that's a good example of biased technical change. So this is where we are. We've got a lot of work today to do today. So if you have a seatbelt, put it on, sit tight, have a sip of water, maybe a chocolate bar, and let's get going. So what we started talking about last time is thinking about costs. Right? The production function just tells you your ability to essentially convert inputs into outputs, so labor and capital into actually produce goods. Now we're back in the short run where one of your inputs is fixed. In economics, it's always capital that's fixed because it's just simply easier to add more labor than it is to add more capital in most settings. So in the short run, where one of your inputs, namely capital, is fixed, the total short run cost is the sum of fixed costs and variable costs. Fixed costs is your capital expenditures, so the price per unit of capital per unit of time times the number of units of capital you're using, right? So expenditure on capital plus variable costs, which is going to be hourly wage, times the number of worker hours you use. So fixed costs are capital costs, variable costs are labor costs. If we think forward to long run costs, in the long run, all costs are going to be variable because all inputs are variable. But in the short run, you have these sunk capital costs. Now, the sunk cost concept is a really sort of weird counterintuitive concept, and we talked about this last time with the supermarket line. But this is how economists live their lives, right? If you've had sunk costs and you cannot recover that investment, that's really important. If you can recover part of the investment, this doesn't apply. But if they're truly sunk costs you've paid, you can't get your money back, those sunk costs should not influence your decision, right? You should decide about what the marginal change is due to your change in behavior. So here, what we'll see in the short run is that firms will ignore these sunk costs when they make decisions. Doesn't mean they don't have an impact. Having waited 25 minutes at Whole Foods while my son Noah throws peanut butter cups at you is, you've suffered, but you're never going to get these 25 minutes back. If I don't prepare for a lecture and I come in here and don't do well and you understood nothing and it's just a badly prepared lecture, you will never get those 80 minutes back, right? It's a sunk cost. So the point here is if you can't recover the cost, those sunk costs should not influence your behavior. And we'll see how this works for firms specifically in a second. So we're going to need some new language, okay? Economists like the word marginal. Marginal, if you have had calculus, who here has had calculus at some point in their life? Many of you, right? So you remember this business of taking partial derivatives at any point on a function, and it tells you the slope of the function at any point. So the total cost here is fixed cost plus variable cost, like I showed you earlier. There's another concept here called marginal cost. Marginal cost is to total cost what marginal product was to total product. Marginal product was the change in output due to a 1 unit change in labor. Marginal cost is going to be the change in total cost due to producing 1 more unit of output. All right? Note that for marginal product of labor, it's change in output due to a change in labor. Marginal cost is going to be change in cost due to a change in units of output. Right? So what's going to go on the x-axis for cost is going to be quantity, as we're seeing in a second. When we're talking about marginal product of labor, labor goes on the x-axis. But the concept is the same. How much does your cost in the short run change if you produce one more unit? Or more simply put, what's the cost of increasing production by 1 unit, starting at the point where you're producing? So this is the word definition, but the math definition, which looks really intimidating, right? It has a delta in it. Whoa! Marginal cost, so we use a very creative abbreviation, MC. Delta TC just means the change in total cost, this is in the short run, over the change in quantity. So this is rise, change in cost, over run, change in quantity. Marginal cost, as we'll see in a second, will depend on where you are on your total cost curve. And I'm going to give you an example of a total cost curve, and we're going to derive these marginal cost curves in a second. But marginal cost at low levels of output may be very different from marginal cost at medium or high levels of output. So it depends on the starting point, right? Maybe producing the first unit is much less expensive than producing the 512th unit in the short run. The next concept we're going to introduce here is something called average fixed cost. That one turns out to be not very important. It'll be helpful in drawing certain curves, but it's something that comes up in your textbooks and is important to define. So you have a bunch of sunk costs, right? You spend some money on capital, you can't recover it. Maybe one number you'd want to know is at a given output level, per unit, how much of the cost that I produce per unit is actually fixed cost versus how much of it is variable cost. Or since in the short run our fixed costs are capital costs, average fixed cost measures out of the total cost per unit, right? How many dollars of that is actual capital cost? So it's the average fixed cost per unit produced. So if the average total cost of a unit produced, let's say you're producing 100 units, you're spending $1,000, right? The average total cost is $10 per unit. What average fixed cost answers is out of those $10 per unit, how many dollars of that is actually spent on capital versus how many dollars of that is actually spent on labor? That's the average fixed cost. It's measured in dollars per unit. Average variable cost, of course, is then the complement to that. So we know that, let's say you're spending $2 per unit on capital. Average variable cost tells you per unit how many dollars are you spending on labor. So it tells you in some sense the mix over all units produced on average, how many dollars per unit are you spending on capital, average fixed cost versus on labor, average variable cost. We'll stick, I'm not going to do any trickery on any exams or anything like that where all of a sudden labor is fixed and capital is variable to throw you a curveball. That's nonsense, right? I know you guys are way smarter than that. So capital will always be the fixed thing and labor will always be the variable thing. Of course, you can come up with examples where the opposite is true. If there are rigidities in labor markets where you can't hire more workers without going through 6 years of union negotiations or something like that, it may be the other way around, that it's easier to add capital than labor. It's possible, but in most settings, capital is the thing that's fixed. So average total cost is the average number of dollars it costs you to produce 1 unit. I feel a little bit like I'm in a, come on. I was going to do that, it's like a Harry Potter thing. There we go. That was a little Harry Potter-ish, I liked. So average total cost is just the sum of these two, right? It's on average how many dollars are you spending on producing the average unit you're producing. Of course, average total cost, the number of dollars per unit, is made up of average fixed cost and average variable cost. Since you're only producing 2 types of inputs, fixed and variable, the sum of those two have to add up to average total cost. Max, that was totally easy. I get it. Don't bother me with a spreadsheet. But we love spreadsheets. And oh my God, that Noah. He got his new eraser and he erased a couple of numbers. Can we fill in some stuff? Yeah, we can, right? So what we've got here now in the first column is our quantity, meaning how many units of output are you producing. I'm going from 0 to 12 units. The second column here, F, is total fixed cost, meaning how much are you spending on capital. Since capital is fixed, right, the total expenditure on capital is also fixed. So I'm saying you're spending $48 on capital in this particular setting. And then variable cost depends on how much output you produce. Okay, so if you produce more, since capital is fixed, the only thing you can add to produce more output is labor. So you're spending more money on labor as you produce more output. So variable cost, and I've used a specific functional form here, which you can ignore for a second, goes from 0, where you're producing 0 units of output, to 321, where you're producing 12 units of output. Total cost is just the sum of fixed plus variable cost. So you sum these two columns. You can use one of your fancy functions, equal sum open bracket, this to this, close bracket, and Excel will spit out that number for you. But my 5-year-old dad, dude, come on, what you do? Let's figure out whether we can do this, right? So this here is total cost. 48 plus 46 is 94. So what's total cost here? It's got to be fixed cost plus variable cost. So 48 plus 66, that better be 114. You can use your iPhone technology or Android if you want to check my math, okay? Again, here, same thing. You know what the total cost is. It's 168. You know fixed cost is 48. So variable cost has to be 168 minus 48. It's got to be 120. I've had too much coffee today. I'm shaking a little bit, so I apologize for my handwriting. So the next thing we want to worry about is marginal cost. So you can always ignore what happens at 0 because that's hard, and that gets into discussions involving mathematics that are A, useless, and B, really hard. So they're good for a PhD, but not good for practical knowledge, okay? So what we've got here is we're worried about marginal cost. What is marginal cost? Well, if I go from producing 0 units to producing 1 unit, if I produce 0 units, I still have to pay my fixed cost, $48, right? Those are sunk. There's nothing I can do about it. But I'm a social scientist, for crying out loud. Here we go. That was smooth. So marginal cost tells me how much does total cost go up by if I produce 1 more unit. If I go from 0 to 1, fixed cost doesn't change, right? The only thing that changes is variable cost, and total cost goes up. Do variable cost and total cost go up by the same amounts or different amounts? Same amounts, right? Since the only thing that changes is variable cost, the only change in total cost is the change in variable cost. So you can get marginal cost from the change in total cost and the change in variable cost. 25 minus 0 is 25, but 73 minus 48 is also 25. So marginal cost is either the change in total cost due to the change in output or the change in variable cost due to the change in output at any given quantity. They're the same thing. If you do the same thing, you go from 1 to 2 units, you go from 25 to 46, you add 1 unit of output, so change in Q is 1. Change in output is 46 minus 25, that's 21. Again, let's check if you see the same thing in total cost. 94 minus 73 is also 21. Oh, again, that Noah, right? Let's check our understanding. If we go from 2 to 3 units, variable cost go from 46 to 66, so change in variable cost is 20. Change in output is 1, so marginal cost is 20. Can we get the same thing off total cost? 114 minus 94 is 20. So that blank number here should be a 20. So hopefully that makes sense, and the rest of this is consistent here, as I did use a spreadsheet technology, very, very 2014, to make sure that these numbers are right. Did I screw up here somewhere? Oh, I put the 20 in the wrong, no, I put it in the right place. 20 and 20, they happen to be true in both places, right? Beautiful. Just to be clear, you should never mumble to yourself and assume everybody understands, right? We go from 100 to 120, and 148 to 168, so marginal cost is 20 here. Here we go from 94 to 114, and 46 to 66, so it's also 20 there. So that's marginal cost. Average fixed cost, what is average fixed cost? Well, I can't memorize these things, so average fixed cost is simply total cost. Whoa, this is terrible. Average fixed, it's getting worse, is fixed cost over quantity, okay? That looks horrible, but it's on your previous slide, so it's not so bad. So average fixed cost, you just divide your total fixed costs, which are F here, by output. Since you're dividing a constant number over more and more output, what's that going to be like? What does that look like? It's just like a, right? Like the average, well, I'm not going to make that joke. But the point here is it's 48 divided by 1 is 48. Then it's 48, which is still my total fixed cost, divided by 2, should be 24. 48 divided by 3, 16. 48 divided by 4, 12. You can just keep on going, and average fixed cost just keeps on falling. So the missing value here is going to be 48 divided by 3, and that's going to be 16. Average variable cost is very similar, only here you're dividing total variable costs by output, right? So 25 divided by 1 is going to be 25. 46 divided by 2 is going to be 23. 66 divided by 3 is going to be 22. You keep on going. The next missing one to check our understanding here is 48 divided by 6, so that should be 8. No. What am I talking about? Less coffee, Max, before lecture. Lesson learned for next time. Total variable cost, right? Average variable cost is total variable cost, 120 divided by output, so 20, right? Okay. Average total cost is simply total cost divided by output. So total cost is the sum of fixed plus variable cost. So add these two, you get this column. To get average total cost, you divide this column by that column. So 73 divided by 1 is 1. 94 divided by 2 is 47. 114 divided by 3 is, are you volunteering the answer? All right, let me fill in my table and then I'm going to answer your question. Is that okay? All right, so 114 divided by 3 is 40 minus 2 should be 38, right? Question mark means Max has slight uncertainty whether his ability to do algebra in front of 200 people is good. It's correct, I like that, thank you. So 168 divided by 6 should be 30 minus 2, so 28. That should also be right. Right? So while filling in tables in front of a bunch of students who've paid good money to be in this classroom seems like a really boring exercise, what have we learned from midterm number 1? Doing boring exercises and practicing this over and over and over again is really important, right? So what this table gave us, it showed us the numerical relationship between fixed cost, variable cost, and total cost, and how off of variable and total cost we can get marginal cost, how off of fixed cost we can get average fixed cost, how off of variable cost we can get average variable cost. And once I know average fixed and average variable cost, I don't actually need to separately calculate average total cost, but you can just sum these two columns. So 16 plus 22, 38. 8 plus 20, 28. So you can check that you're doing right by either adding average fixed and average variable cost or actually calculating average total cost to get average total cost. You had a question? All right, I like that. This is a new thing I learned whenever somebody answers my question in the seminar, you yell, asked and answered. That way you seem smart, right? And don't take up people's time. I like that a lot. So when a Nobel laureate asks a question before you, just afterwards say asked and answered by the Nobel laureate, and that's a really good strategy. I'm joking. Okay, so what I did here, and we're going to draw this by hand in a second, but to spare you the painful exercise of actually plotting total cost, which is blue, this is Cal colors, please note, triangle with yellow in the middle and blue solid line, I plotted my total cost curve. So if you look at your table, on the x-axis here we have output, on the y-axis here we have the total cost that you see in the table. So each point on that blue line here represents the total cost of producing whatever output level you have on the x-axis. So that's a beautiful thing, right? If we had to draw this thing just shape-wise, because it's so stretched out with these new screen formats, it really actually looks a little bit like this here, right? Has an inflection point, looks a little bit S-shaped. If you squish it together, you can see that better. So that's average total cost. So that's total cost. That's total variable plus fixed costs. So what do fixed costs look like? At any level of output, I pay the same dollar amount on fixed costs, So at any level of output here, starting at 0, going all the way to 12 here, does my fixed cost change? No, that's why it's called a fixed cost, right? So it doesn't change. It's constant at $48. So total fixed costs are these is this blue line with the rectangles right here. Fixed costs are $48 at any output level. So what's variable cost? Well, variable cost is total cost minus fixed costs, right? So what I do is I just take my total cost curve and I subtract from it my fixed costs, which is constant, which simply means I'm going to take my total cost curve and I'm going to shift it down by fixed costs. Since you kids grew up in a world of copy and paste and move stuff around and the ability to click stuff and drag it everywhere, it's like click this, select the whole element, copy it, and drag it exactly vertically down by 48 units, and you have total variable costs. The other way to do it, of course, is the other way around. You plot total variable cost